What would it take for interstellar travel? What are the most promising technologies to further space exploration? How do we become a multiplanetary civilization? I am Bhavyathir V. Bharadwaj. Welcome to episode 8 of Genesis of Tomorrow. The following is a conversation about astrophysics, aerospace, cosmic exploration, space, therapeutics, reusable launch vehicles, interstellar travel, and more with Miss Viktoria Urban, who has a widespread experience in science communication, a passion for space and cosmos, and is currently working towards a PhD in neuroscience to research the effects of deep space travel on the human brain. Also, 86.1 of you watching this have not subscribed yet. If you get even the slightest bit of value from our show, please support us by clicking that subscribe button so that we can keep on improving the quality of the episodes and keep on bringing such wonderful guests over for you. And now, without any further ado, let's get right into it. Enjoy and thank you. My motive with this particular episode is to talk to you about where humanity is headed, and space science and technology invariably is a subset of that discussion.
Mhm.
And what a better way to start understanding that, the future of humanity, than to first put through a fundamental basis of where we are today.
Well, in terms of space, this is a very exciting time. We are heading back to the moon. We want to establish permanent human presence on the moon, and then we eventually want to go to Mars. So I think this is a very exciting time with technological advancements, and the human side is very interesting as well, because obviously we're training more astronauts. Um, what I want to do in the future, which is neuroscience, is very happy about this as well because we get to examine humans before they go to space and after they've been to space, and they're most likely going to spend longer um, terms in space than right now on the ISS or any other space stations. Obviously, there are a lot of companies, or more and more companies, coming up with ideas for commercial space stations. So there will be more humans in space than ever before. They're working on hibernation. If they could master that for humans, then we could think about interstellar travel in the future, obviously, not in the near future. So this is where we are at the moment.
In continuation to that, because I feel it's a very intriguing aspect or implication of space travel. What happens or what implications does the human brain suffer through due to spending elongated periods of time in that extreme environment?
Well, you know, the psychological effects have been studied for a long time, and NASA has a little handbook as well, what to do if, you know, a mental health crisis happens in space. So obviously, isolation is a big part of that. You can't have panic attacks in space because you can't just, you know, go outside for a walk or open the window for fresh air. Um, you have a lot of things that happen to your body in space. So physically, a lot of things change that had an effect on your brain as well. The fact that there's microgravity. So if you want, I don't know, a hug from another human being, it's not going to have the same feel as on Earth because there's just no weight to that body that you're holding, which could be weird. Sleeping, again, you have to be strapped down. To be able to sleep. Otherwise, you just float about. You see 17 sunrises a day, so there's, you know, the circadian rhythm of the body is totally different or non-existent in space. So the psychological effects have been um, examined and researched for a long time, but we haven't really looked into what happens to the brain physically. So with MRI, fMRI scans, We haven't really done that. We only started doing that in the past 10, 15 years. So we still don't have a lot of data, and that's why it's so exciting.
Also, currently, right now, reusable launch vehicles are the current fuss that was going around with
Oh, yeah.
SpaceX launch and everything. Yeah, what according to you is this future of space transportation? After companies like SpaceX and Blue Origin have been making significant strides in the area with their technologies of Falcon 9 or maybe New Shepard, what is the future of space transportation?
Well, the near future is Starship, I think. Starship is in a very good position at the moment. They have successful tests now. In fact, there was a launch just last night. I think there was no capture this time. I haven't seen it. Um, a Starship is going to be a successful venture in the near future. So they're going to use it first to um, transport people to the moon, and then it can be used to go to Mars, for example. That's one thing. Obviously, countries like China, they're working on reusable rockets as well. I think that's the way to go. Reusable rockets for sure. We will have to consider the environment, the atmosphere more because rocket fuel damages it. So we have to think about sustainability more for sure, um, especially if we're going to launch every single day from multiple places on Earth. We have a rocket launch basically every single day now, but more and more countries will join in on that. So we have to think about sustainability for Earth and low Earth orbits. Um, I don't know, a space elevator, space lift could be cool. They've been theorizing that. Um, yeah, but I think SpaceX is the most advanced and Starship, obviously.
Very briefly, at the start of the conversation, you mentioned about interstellar travel in a different
Yes,
connotation, but still, let's talk about that for a little while. The main, the main challenge at harboring that technology is the question of propulsion systems.
yes.
What are the different theoretical propositions in regard to varied propulsion systems that might be used in these interstellar engines or machines?
Well, what they have big hopes for is nuclear propulsion, so nuclear fusion. Um, they say that could be the answer to um, the problem of interstellar travel or the issues and the challenges that interstellar travel poses. They are working on that, several companies. There's one in the UK, Pulsar Fusion, I think is the name. Um, but it will take a long time to perfect that technology. Solar sails are another way to go, but that's not as fast because obviously if we want to go outside of the solar system, that will take years and decades. Um, and we need to be faster than that. So yeah, nuclear propulsion is the biggest hope.
What about utilizing resources from space? Because energy is again not only required for transportation, space transportation and commutation, but also the depleting of the current sources of energy that we are utilizing on Earth. We need newer and novel energy sources.
Oh
How
yeah,
do we harness resources from outer space to do that?
like what resources?
Maybe
what
solar
we can
energy or
harness.
probably finding. Hmm.
Mhm. Sorry, no, go on.
Yeah, maybe solar energy, having giant solar panels
Hmm.
outside the orbiting the Earth, because that is definitely a method that has been proposed in theory. The other one, coming across space mining, is one of the futuristic aspects of space exploration. So, coming across a mineral ore or crude resources that might help us to generate energy in a more efficient way than we are able to do with the current fossil fuels and resources present on Earth. So, like,
Right.
what is
So,
this entire proposition?
okay. Yeah. So solar power, sure. Um, that's why I mentioned solar sails. That's another way to go. But if we think about space mining, so space mining is not easy, or asteroid mining, sorry. Asteroid mining is not easy because you obviously have to time it perfectly so that you land on the asteroid, which has been done, so it can be done, we know that. But then you have to make sure you get the samples or the material you want from it, and then the difficult thing is bringing it back, because you have to bring it back. And they're working on it. It's a plausible idea, obviously. I'm not sure what new energy sources we could find on an asteroid, because we were all made from the same material. So I'm not sure if we would find anything that could help us more than what we have on Earth or around Earth.
But okay, we really might find resources that are probably depleting on Earth, but might be abundant in those asteroids.
Yes,
And
sure.
then comes the question about the equality or the equilibrium of distribution of those resources, so that no particular company or country has a hegemonic rule over that. Like, what do you think would be the
Yeah,
dynamic of the world when we reach the state in advancement where we can do all those things?
yeah. See, the problem is always humans, right? So, space law is actually what's dealing with this problem. Space belongs to no one and everyone at the same time, but then again, the country and or the company who reaches these resources first will definitely claim ownership of them. So unless we come up with strong, enforceable laws for space, we, you know, these companies and countries will just say that it's theirs and they wouldn't want to share, and there's no way we can tell them they have to. So that's the first thing. Space law is very important and very difficult to do. We need international cooperation. We would need data transparency, and everyone should adhere to these laws and regulations. But as we can't even manage that on Earth, I'm a bit skeptical as how it will work out in space.
I was really intrigued. I got to know about the UN's United Nations treaty, this joint space outer space treaty, if I'm
Yeah,
not getting the name wrong. It specifically prohibits the weaponization around the orbit of Earth,
yeah,
because initially during the space race, UN was really worried about the possibility of having satellites armed, and then armed with nukes or other biological
yeah.
or chemical weapons, and then be used as a sort of space fortress to target and cause destruction on Earth.
Hmm.
So, I mean, there are umpteen things with space exploration and space science in general that have a very double edged nature, as with
Sure.
science in general. But when we talk about this ethical and moral side of things, what do you think is the most significant aspect of this entire discussion?
Right. So what you mentioned would be very important to come to an understanding and an agreement that no one should have weapons in space. That's never going to happen. Um, Countries will have weapons in space. Certain countries, not all of them. Um, I don't know. It would be important to understand that what we do in space has an effect on Earth. Like if you nuke the satellites in low Earth orbit, that won't just affect the satellites, it will affect everything down on Earth because we use satellites in our everyday lives for everything: GPS, banking, telecommunications. So if they nuke satellites, then we're fried on Earth as well, so to speak. And then it has other implications as well. So it would be very important to come to an understanding, but as I say, we couldn't do that on Earth. So why do we think that we could agree on whatever happens in space? I don't know. Space law is very interesting, very hard, and it would be extremely important.
What has been your personal journey, or probably paraphrasing that question, how did you harbor this interest or inclination towards the domain of space sciences and technology?
Right. So I was always interested in space, but I never thought I was smart enough. And I would like to encourage everyone who thinks like that to leave that thought and just go and try. Um, because once I got the courage and I started studying astronomy and planetary science, it turned out that I was smart enough. And as I had a journalism degree already, I started writing about space and all the conferences that I attended because I think there are important conversations at these conferences that are not communicated to the general public. And that's what I wanted to do. Instead, I ended up working for several space magazines, which again are very specialized. So the general public still doesn't know a lot about the problems and the challenges of space and why it is important to go to space. And that's another thing that would be important to teach people, educate people about the importance of space, because they think that space companies and governments spend way too much money on space rather than focusing on sustainability on Earth and other things. Actually, climate change is monitored from space. So, space has a lot of qualities that we could harness here on Earth, and people don't realize that. But anyway, I digress. And once I started attending these space conferences and started meeting and talking to astronauts, that's when I became interested in what happens to humans in space and what would happen to us if we colonized another planet. Um, how our genes might change, what would happen to the brain, and that's how I ended up in this line of studies. But yeah, so this is another important thing that I want to emphasize, that educating the general public would be important. Just as we had David Attenborough for Earth to talk about animals and sustainability and the oceans and how polluted they are, it would be important for people to understand that the challenges of space make humans come up with technologies that we never thought of before because we didn't have those challenges. And they make life easier on Earth. And there are a lot of things going on the ISS, for example, a lot of research that would help our lives in the future. Um, yeah,
I really agree to that. Science communication really helps bridge the discrepancy between the people who are very well versed in the scientific language and terminology and the general masses,
sure.
and becomes even more significant to not let that divide grow greater
Yeah,
and greater.
yeah,
What,
definitely.
according to you, is the most significant thing in order to make sure that people in this domain, science communication, are able to properly convey the ideas of the scientific community to the general masses without oversimplifying that? Because that often is the
Hmm.
greatest bit that you can fall into, like while you're conveying these complex mathematical and uh, really complex ideas and theories, it's important to explain it to the wide public without leaving behind the nuances and intricacies of it. So how
Sure.
does one manage that perfect balance?
See, what I've seen in the industry is that engineers, however great they are in what they do, are not necessarily the right people to communicate what they're doing and how significant their work is. So we need more professionals, science communicators, who are familiar with space so they understand what's happening, and they can also communicate it. So we don't just need journalists who write about space, we need journalists who understand space and science so that they can publish articles and, you know, broadcast um, things that are like in the middle ground. So they're scientific. If you want to look deeper into it, you can, and it's not like written for children only. That's important too, um, but not to oversimplify it. I agree, um, because people can look things up. Like if they read an article and obviously things are explained in that, but something catches their eye, they should be able to look things up and research for themselves and understand. So we need more people who work for these companies and governments, and we need the companies and governments to understand they need these people, because that's one thing that they don't do right. Many companies don't think that communicating what they do to the general public is important. They just focus on their clients, and that's not right. It would be important for um, everyone to understand what they're doing because they would get more support from the government and the public for their work.
What, I'm a science communicator, right? And I've just begun to enter this field and domain. What
Yeah.
are few key skills or attributes that I must look forward to imbibe in myself or inculcate in my work?
Networking is very important, I think, in science communication. So you have to have a good network, people you can turn to for further explanation, uh, people who can give you information that you otherwise wouldn't have. Um, I don't know. Obviously, if you're a communicator, you can write and you can speak, so that's good. Public speaking, very important, and you will do it a lot as a science communicator. Um, you really have to understand the science behind what you're writing about. Otherwise, you can't summarize it efficiently. What else? I don't know. I think networking is one of the most important things. So to establish a network of experts you can turn to if you don't understand something or if you want to know more about the geopolitical side of something or the engineering side. And when you write about a subject, you have to think about all these different aspects. So it's not just, oh, this is a cool technology and this is what it looks like, but you also have to look into how it's going to impact the current technology, future technology, and where is its place in a geopolitical context.
Also, I was curious about this. When they decide to send a human to space, an
Yes.
astronaut, are there particular traits or probably a set of psychological markers that they look for in them,
Oh,
or is
yes.
just the training and the studies?
No. So right now I'm actually making videos about this. Back in the day, it used to be fighter pilots, you know, who were in the military, had a stable psychological background, and they knew how to fly fighter jets. That's not the case anymore. They're looking for anyone from master's degree and up. And obviously, if they have a science degree, that's that's a good thing. If they served in the military, of course, that's a plus as well, but they don't have to. We're also not looking, or they're also not looking for people who are able-bodied or 100% healthy, you know. We're sending up disabled astronauts now, and there's a reason for that. So we're doing more and more research. Like when you when you're in microgravity, all the fluids from your legs or lower extremities go up into your head. So that's what's called the puffy face and chicken leg syndrome. And they, for example, want to examine what happens to disabled astronauts when there's no gravity, um, and there's no need for them to use their legs. What happens to their body, and what changes occur? Or um, some people, I think it's deaf people who have their crystals in their ears, they're arranged differently. So they also want to check what happens to them in space, in microgravity, where everyone gets disoriented because the crystals rearrange because there's no gravity, and you don't have a sense of up and down, you know. And they want to check what happens to those people who are different on Earth. Um, Sorry, I'm going on to what was the question?
What are the
Oh,
key
okay, yeah, yeah,
psychological
and
markers that they look
yeah,
for in astronauts?
and psychological markers. There's always a clinical psychologist who examines these people. It's part of the recruitment process. So I don't think you can even get to the second stage unless you had this psychological um, examination.